So then Stinger 7. Again, it may only be like a couple of you that I could be available. Of course, there's after school Wednesday, after school Thursday this week. Next week, only after school Wednesday, because a week from Thursday, 10 days from today is the last day of the quarter. It's the last day of the quarter. And after that, that's it. That's a 2-hour early release. And that's also no after school next Thursday. However, between now and then, look at SIS. Think about what you need to, have to, or must do to get your grade to where you want it to be before the end of the quarter. Now, some of you are in really good shape. There's about 4 or 5 of you are in great shape. You're not gonna fail at all. But then there's about similar number of you who are in a position where you need to get work done. Time is about up. So I'm going to leave it at that. At this point, we're going to move on. All right. So new unit, let's begin. Regular polygons. Now, we do have a couple questions about polygons. First off, well, you have definitions. Polygons, closed figure, straight edges, none of the sides cross. And then there are 2 types of polygons. Convex, all the vertices turn outside, but they're not turning inward. Whereas a concave, you have at least one vertex turning inside towards the center of the polygon. So we look at these 6. We need to figure out, is it a polygon, yes or no? If it is, convex or concave? If it isn't, you tell us why. So, first one. Polygon, yes or no? Or all the side, is it a closed figure? This triangle looking figure. Are there any open sides? No open sides. Are those edges straight? They're not curved? All right. Now, so we have a polygon. Corners. Are all the corners facing outwards, or do any of them turn in? Most of them are. Like that. One of them is inward. This guy right here. That makes it turn in towards the center. So is that convex or concave? Well, in the end, this polygon is going to be a concave. Reason being, see that turn inwards? Right there. Is the reason why that's going to be a concave polygon. What about this next one? That also polygon, yes and no? Yeah, that is also a polygon. Now, are all the corners facing outwards, or do any face inwards? They're all outwards, so that is convex. All right, what about this one? That's a polygon as well. Is that also convex, or is that concave, or are there any corners that face in towards the center? Or do they all face outwards? That's also convex, yep. All face out. All right. What about this one here? Unlike the other three, what do we have going on here? Is that a straight edge or is that curved? So is this a polygon, yes or no? No, not a polygon. Yep, that looks like a pizza slice. So pizza slices are technically not polygons, unless if you make it them square ones, rectangular ones. What about E? Polygon or not a polygon? Well, is that figure totally enclosed? Yes or no? No. It was not a polygon. Open edge. And then the last one. What about this one? Polygon or not a polygon? Well, what's going on? Do any of our sides cross? Yeah. So, sides cross, not a polygon. All right. So, we're going to be dealing with polygons, so not just triangles. We're going to be dealing with polygons as well. All right, questions on this first slide here. All right, next slide. Well, there's three types of polygons. Equilateral, the sides are congruent. Equiangular, angles are congruent. And then a regular polygon, sides and angles are congruent. So we have three types of polygons. All right, this first one. Notice how all the sides have that little dash mark. So who could tell us, what do we know about all those sides that have that little dash mark? All right, do we hear what we just said about all them sides on that first polygon? What about them? He said it. Say it again. I don't think everybody heard you. All sides are congruent because they have that little dash mark. Anytime you see that dash mark on two or more sides, sides are congruent. So in this case, since all sides are congruent, it's going to be equilateral, the first one. So all the sides are congruent for the first one. Now be careful. The second one, are the sides necessarily congruent? But what are congruent? Angles. So rather than equilateral, it's equiangular. Equiangular. Because unlike number 4, number 5, your angles are all congruent to 90 degrees. So only the angles are congruent. Here, only the sides were congruent because we can tell the angles aren't congruent for all these. Because this angle right there was way different than that one. And then this one's different from all the others. And then what about this last one here? Sides are congruent. They have that single dash mark. Angles are also congruent because they all have that same single arc. So in this case, if the sides and the angles are congruent, this is a regular polygon. You don't have to put the word polygon, but this case is regular polygon. All the sides are congruent, all the angles are congruent. And we're going to be dealing with regular polygons quite a bit this upcoming unit. All right. Questions before we move on? So these first two slides will be sort of good to know. Now, next thing I want to talk about. For those of you who came in late, whatever you missed, you got to get from the neighbor. Now, another thing that we're going to talk about, your diagonals. Now, diagonal is when you start from one corner and you go from one corner to a different corner. So like this or like this. Now, you got to be careful because when we deal with number triangles, I want you all to know something. There's going to be two different times we're going to see diagonals. One time you see diagonals is when we determine the number of triangles that are formed from each polygon. But it's going to be different than when we deal with other types of problems when we're dealing with angle measurement. Because we could see diagonals cross, but if we're dealing with determining the number of triangles, then the diagonals cannot cross. So if we want to figure out number of triangles in each polygon, then what's going to happen is we start from a corner, draw a line to a different corner. Now once you draw that line, if we're dealing with number of triangles, then we can't cross from here to here. And it has to be non-consecutive because if we draw a line, let's start here. And I can't do it like that because then basically you just drew a line over the original edge. So that cannot work. Now, a couple quick things. With triangles, how many degrees must be the sum of the three angles inside a triangle? Any triangle. If I have three angles in a triangle, what must the sum of the three angles add up to be? How many? 180. That's something we need to know, like bang, bang, bang. Now, but here's how that's going to be important. Don't worry so much about this. If you draw it drawn, that's cool. But what you do need to worry about is what's next. And that's going to deal with the following. Now, anytime you're given a figure, triangle, quadrilateral, pentagon, hexagon, and so forth, first you get the number of sides, then given the number of sides, you're going to determine the number of triangles. Because what's going to happen is after you get the number of triangles, that's going to help you determine some of the interior measures of all the angles within the polygon, the original polygon. All right, so going back to what we said earlier. You said in one triangle, the sum of the angles was how many degrees? Somebody said it. 180. Now, we look at the next problem. Quadrilateral. Well, how many triangles do we see in that quadrilateral? 2. If we see two triangles, then how many degrees? So if one triangle is 180, that means two triangles is how many degrees? What's 180 times 2? 360. What about the pentagon? So that means, okay, if we have three triangles, 3 times 180 gives us what number? So we need calculators. We should be opening up calculators and doing some multiplication tables. 540. Okay, hexagon, 6 sides. How many triangles do we have? Too high. You have 4 triangles. So we have 4 triangles. What's 4 times 180? So 180 times 4, 720. All right, I want everybody to see a trend going on here. Trend number 1, number of sides. What number did we subtract from the number of sides to get the number of triangles? 3 minus what gave us 1? Or 4 minus what gave us 2? Minus 2. Oops. So we want to go from number of sides to number of triangles. Subtract 2. Then we went from number of triangles to number sum of the interior angles. What number did we multiply by? We just did it a couple times. What number times 2 gave us 360? What number times, how much? 180. So that's going to be the general rule. Number of sides minus 2, number of triangles. Once you get the triangle multiplied by 180, you get the sum of the interior angles. So that's going to be something you're going to need to know. Now, the next slide is going to be basically the same thing. So once everybody copied down this information, we'll go to the next slide. So do that in a second. So let me check attendance real quick. All right. Are we ready for the next slide, ladies and gentlemen? Okay, basically what you're going to do the same thing. So I want you really quick. I finish up attendance. Fill in this next column. Something times 180 in all them cases. Fill that in real quick. That should only take you about 30 seconds to a minute. Finish up attendance. Again, some of us really need to get here on time. For a lot of you, thank you for arriving on time. All right. So really quick. What do we get over here? What's the next one? And the following one. Then, oh, good job. 1440. There we go. Questions? Again, number sides, -2, number triangles. Number triangles times 180, sum of the interior angles. And we're going to need to know this. So this page in particular, you do not want to lose it. So it's a one page. And we're also going to talk about the rules in general. But this page in particular is going to help us with a lot of the problems that we're going to be doing later today. So you don't want to lose that page. All right, do we have all them numbers? Cindy, did you get them numbers? All right, I'm going to move on. And again, well, we'll talk about this one in a moment. But first off, and I'll add the disclaimer real quick. All right. And number of sides. Actually, don't see it too much. And then I'm also going to tell you n minus 2 equals number of triangles. These are the two of the most important rules you need to know. I should say number of triangles of a polygon. There you go. These are the rules you need to understand. And then the sum of the interior angles. So let's say you want to figure out what must be the total number of degrees inside whatever polygon. Take your number of sides, subtract 2, multiply by 180. Now, this other rule, the key word is it has to be a regular polygon for this to work. And does anybody remember from what we talked about earlier, what is a regular polygon? We know about the sides and the angles of a regular polygon. All equal. So that might be something real quick you might want to write down. Especially for anybody who came in late today. So I should say all sides and angles are congruent. So regular polygon, again, all sides and angles of the polygon are congruent. If you're okay with it, you don't have to write it down. But if you need to, for your purpose, that's fine. All right, questions before we move on? Again, All you really need to know is the number of sides. Once you have that, then everything else is just a plug in. You just have to figure out when we use what definition or what formula. Questions before we move on? And for most of these problems, you're going to get the list of the formulas. All right. Any questions, or are we ready to go? Again, them phones aren't going to help you. All right. So now, the question is, which formula do we use? Do we use sum of the interior angles or the measure of each interior angle? All right, so let's look at the first one. Find the sum of the interior angles of a 15-gon. Now, in this case, well, first off, we have to figure out what's the value of n. So anytime they say something gone, a number dash gone, because after like 10, they just do like whatever number dash gone. That's how many sides in the polygon. So in this case, a 15-gon, I'll tell you right now, n is 15. So now the question is, do we use this formula on the left or the formula on the right? Use the one on the left. This one right here. So basically, you could do this in one shot in your calculator. Place the n with the 15, and you're just going to type it in. 15 minus 2 multiplied by 180. That's all you have to do. That's all you have. If you type it in, I'll make it bigger for you all. So that's exactly all you, that's the quickest way. Type it in. That's how you're going to get your answer. You don't even have to do. That's all the math you really need to do. Anybody get a number? How much? 2340, yes or no? So if you're not sure, 15 minus 2. You got to do that first. 15 minus 2. Well, what's 15 minus 2? 13, and then what's 13? Then you multiply 13 times 180. You should get 2,340, and then degrees. But yeah, that's all you have to do. Now, 2 is the same as 1. Only difference, number 2 and it's 21. The idea is the same. 21 minus 2 times 180. So that's all you have to do. Type in exactly what I wrote on that cap, what I wrote up here. And what do we get? What you get, Alexander? 3,420. We agree? All right. Yep. That's all. All right, questions on that one? All right, now the next one's going to be a little more work because unlike these two, you're going to do almost the same thing, but then you're going to have to divide by the number of sides. Because we want the measure of each interior angle. Now, in this case, the first one is a pentagon. So how many sides are in a pentagon? Pentagon has how many sides? 5. Now, if we want the measure of each interior angle, which one are we using now? The one on the left or the one on the right? The one on the right. So it's almost like the one on the left. Subtract it, number of sides minus 2. Multiply by 180. But then you have to divide by something. Well, what do we have to divide this whole product by? What number? 5 by 5. So this first part, well, what's 5 minus 2? 5 minus 2 is 3. And then we have to multiply by what number? Multiply by 180. So what's 180 times 3? Can you tell us what's 180 times 3? 540. And then we divide by what number? 5 by 5. So 540 divided by 5. 108. Very good. Let me rewrite that. So it's 108 degrees. Okay, what about this next one here? What's the measure of each interior angle of a regular 18 gon? Well, what's our value of n? N is what number? How many sides? So similar up here, 21 gon, n was 21. 15 gon, n was 15. So for this one, n is what number? 18. So then, $18 minus 2. Sorry, it's a little messy here. So it's 18 minus 2 times 180. And then you divide the whole thing by 18. So I want you, so there you go. I want you to help us figure out this one. This one's actually going to be not that bad. So once somebody gets an answer, let us know. I'll give you one other hint. 18 minus 2. Follow order of ops first. And what do we get here?
16 times 108 is 180 is 2,880.
All right, and then what do we divide that by?
18. Then you get 160.
160. So this whole thing in the end becomes 160. I'm going to show you real quick. Also, well, if you think about it, what's 180 divided by 18? 180 divided by 18 just becomes 10. So in the end, you're really just multiplying 16 times 10. That's how you get 160. Very good. But yeah, that's all you do. Questions? So let me write that final one here. So 100, oops, let me actually, I'll use the blue. $160. Any questions? Yeah.
Oh, no, can I use the button?
Where's your agenda?
Oh, I don't have one.
How many times has it been this quarter?
I don't know.
All right. Did we get the 160? All right. Okay, so we got all these. So the difference, you just want the sum of the interior angles. Take your sides, minus 2, multiply by 180. That's it. You want the measure of each interior, same thing, but then divide by the number of sides. That's how you're going to get measure of each interior angle. And that's if it's a regular polygon. If it's something different, whole different ball game. All right, next slide is just a general rule. No matter what type of polygon you have, the sum of the exterior angles. Exterior, is that inside or outside? We're talking about the exterior, like an exterior of the house. Are we talking about inside or outside the house? Outside. And so it's going to be like, basically it's going to look like, I'll just give you a quick example. So here's your polygon. This part here is an example of exterior angle. Okay? Or if I did this, same thing. That's what I mean by the exterior angle. All right, questions? All right, here we go. So, all the cases, let me make this bigger. We're going to do it on for like the first. We'll do this first one, Ones, actually, we'll deal with the ones on the right side real quick. So I want us to talk about anytime an interior plus an exterior angle. Does anybody remember what the sum is? And this is going back basically to unit 1, or maybe unit 2. If I form a line, it's formed by two angles. What must the sum of these two angles add up to be? Does anybody remember? So if I form a line, right here, that's not the best looking line. This might be a little better. There's my line, right? If I form a line of any type, what must the sum of two angles be to help us form that line? Does anybody remember? Close. Well, 90 gives you the right angle. But if I have two right angles, then it's 180. So the sum from here all the way to here, or we could also say from here all the way to here, let's add up to 180. So now, real quick, if this is 61, then how do we get this angle measured? What two numbers do we subtract? Well, if 180 is the grand total, and we started with 61, well, if we subtract, what's 180 minus 61? We should be doing that in our calculators. 119. That's just subtracting two numbers. All right, let's keep those heads up. Stay awake. I know it's Monday morning. What about up here? I have 79 for this angle. How many degrees is this other angle? 101, good. Okay, and if this angle's 40, this one has to be good. What I want you to do real quick, add up 119 plus 101 plus 140. What do we get? We add those three numbers up. You should be getting 360 in the end. Reason why we did this was because a lot of us this is from unit 1 and 2. These two, now if we have, does anybody remember the word for two angles whose sum is 180 degrees? Begins with an S. Supplementary. The two angles that form a linear angle, the supplementary angles, they have to add up to 180. Basically, you'll see that. You're going to see that for the other three. So, questions on this first one? Basically, you're going to see that for the other three. You can check it on your own. This angle right here, basically subtract each number from 180. We're going to go clockwise, basically. So you can check it. So basically, 56, 104, 91, plus 109. Basically, I just went clockwise. You can check it. Six, 104, 91, and 109. We add those up, do we get 360 rather? Would we get 360 if we add these four numbers up? Okay. So in the end, it's not going to matter if it's a triangle, polygon, rectangle, or in this case, trapezoid or quadrilateral, or any of these other ones. These would also be the same. In the end, you're going to get 360. $360. You can check it, but it will work. Yeah, I'll just write the numbers for 50, but then the last one you can try on your own. So the outside is 50, 93, 76, 82, and 59. You can check, add them up, make sure you get 360. I'm not going to do that for you. Last one, same thing. I mean, you could try, you can check. I'll just write them in, but you check. 51, 56, 68. Oh my goodness. 57, 63, and 65. So yeah, you can check those numbers. They should add up to 360 as well. So I'm not going to do that. You can do that. You can do that, not me. What's your gender? There in your back, whatever you miss, you get from a neighbor. All right. Questions before we move on? All right, now, the next set of slides that we're doing, the formulas are already going to be there. You're going to see. I'll make that a little bigger. Again, whatever you miss, you get from a neighbor. That might be too big. Yep, too big. All right. Basically, with the exterior of any polygon, the sum is 360, right? Measures of all the exterior angles. Now, it's a matter of the following. It's a matter of, are we looking for the measure of each angle? We're looking for the number of sides. That's what we have going on here. But no matter what, the exteriors, you're either looking for the measure of each angle or the number of sides. All you're doing is dividing 360 by whatever number they're giving you. So if you see exterior angles, right away the magic number is 360. That's all you're doing, taking 360 divided by whatever number. Either the number of sides of a hexagon or the interior angle of whatever. Just divide. Okay. Let's get to the correct page. I know you're not there. So in all four cases, I'm going to tell you right now, you're dividing 360 by something. So you're already going to write 360 divided by something. Actually, I'll make it easy. Well, first off, with a hexagon, how many sides are a hexagon? It's a hexagon, that means how many sides do we have? Hexagon. That's 6 sides. So all you're doing is taking 360 and dividing it by? Do it. So if it's an exterior, so it's that outside of the hexagon. So what's 360 divided by 6? That's it. Next problem is going to be the same. Start with 360. Well, how many sides? Well, what's the number of sides? If they say 24 gone, that means n is how many? What number? Yep. So all you do, just divide 360 by 24. So what's 360 divided by 24? Good. Now, it's slightly different. They gave us the measure of each exterior angle. So they want us to get the number of sides, but all we have to do is divide. But just like before, you're just taking 360 and you're going to divide by what number in this case? You know, we want to find the number of sides, but we don't have the number of sides, but we do have an exterior angle measure. So what's our exterior angle measure? So we divide 360 by 12. And that's going to give us how many sides? 30 sides. So unlike before, these two, these were the number of sides. Here, they gave us the exterior angle measure. And we get the number of sides. The last one's going to be the same thing. $360 divided by what number? What's our interior angle measure? We divide 360 by 40. Again, what do we get? 9 sides. Anybody have questions? Nice and simple, right? Again, for a lot of these problems, I'm going to already give you the formulas. Now it's just a matter of you using the correct formula or formulas. So it's basically given a problem, execute. That's what it is. We just have to determine, with given the information, which formula do we have to use. And then from there, have at it. All right. Again, this is just a general review of what we've done the whole period today. Sum of interior angles. And don't forget, well, I'll add n equals number of sides. So you get, that's the most important thing. Once you know the number of sides, that's it. But what I'm also going to tell you is one other thing. Let's go down memory lane. Interior angle plus exterior angle equals 180 degrees. That's the one other thing I wanted to tell everybody. You haven't dealt with that in a while. That goes back This goes back to Unit 2. Maybe even Unit 1. The reason why I want to throw that in there is because we saw that a couple problems ago. This goes real quick. I'll just show you real quick. Right back here. There was our example. Interior, exterior. They added up to 180. Same thing here. Interior, exterior. Added up to 180. Do we agree to that? That happened everywhere. We talked about that. Again, that goes back to Units 1 and 2. That's basically almost the beginning of the year stuff. So what we learned in the beginning of the year is coming back with a vengeance. I think I'm going to have to start putting the class warning, first person warning, second person, both people lose their phones, and then some rule back into effect. All right. So this is basically everything you need to know for what we're doing for the remaining of the class period. And then going forward. All right, let's look at these. So basically, we're reviewing for the rest of the period. So this first problem, what is the sum of the measures of the interior angles of a pentagon? Well, again, how many sides give us a pentagon? Well, how many sides are in a pentagon? N is pentagon, people. How many sides are in a pentagon? Pentagon, that means N is 5. Okay, if you want the sum of the measures of the interior angles, which one am I using? First, second, third, fourth, or last? Which one? First. So this, we use this one right here. N minus 2 times 180. There you go. There you go. Just plug it in. 5 minus 2. All right. And somebody could tell us what number did we get? Yup. All right, now, so this problem we had to use the top. Now, when it says what is the measure of each interior angle, well, which formula are we going to use now? Measure of each interior angle. That's exterior. Interior. Not second to last, but second to the. Yeah, it's just a plain old second one right here. You got to use this one right there for number 2. Now, most important thing, octagon. How many sides are in an octagon? Octagon is 8. Think about a stop sign. A lot of you are starting to drive. All right. So all you're doing is just plugging it in. Eight minus 2. Anybody get a number for this one? Yup. So in the end, multiply 6 times 180. Divided by 8. So in the end, you're going to get 135. Very good. Because then it'd be 1080. No, wait a minute. No, I messed up. Yeah, that's right. I mean, 135 is right. Because 3/4 of 180 is 135. So I know 135 is right. All right. Questions? Yeah, that's what you do here. All right, moving on. We all got this? All right, this next one, all right, I think I crossed that bottom problem. Here's what we need to do. This is a two-part problem right here. 5 angles of a hexagon, these are the measures. We need to find the missing angle. Now, first thing we need to do is 2 parts. Part number 1, we need to find the sum of all the angles of a hexagon. However, I gave you a cheat sheet. Go back towards the beginning of today. It's on a chart regarding the sum of the angles of a hexagon. So how many degrees would be the sum of your 6 angles of a hexagon? They add up to how many degrees? Anybody remember? That's a triangle. I want a hexagon. A little further. That's a little warmer. Go back to the chart. There's a chart, I think, on one of the first few pages. That's a quadrilateral. That's only.
Mm-hmm.
720. Because it is 6. So you need to use 6 minus 2 times 180. That's where we get 720. We cheated a little. Because since I gave you that little chart. All right. So that's the first bit. The second bit is the following. So 720 equals, well, what are the first 5 numbers they gave us? Who can read us the first 5 numbers they gave us? Well, what? It's right in the problem. What 5 numbers were given to us? Make it a little bigger, but it's right on your own paper. What were the 5 numbers given to us for this problem? They gave us 5 angle measures. Who could read them off?
Oh, damn.
Yeah, them.
119, 139, 104, 139.
Now, they didn't give us the last angle, but what can we always use for an unknown? Any unknown, we use begins with a V. Variable. So what variable do you want to use? Good enough for me. So X is that last angle. That's the last angle right there. Last angle. But for the remaining 5, well, in the meantime, what do we do with the other 5 numbers? What can we first do to those other 5 numbers? We can, begins with an A. Add them up. So let's add those 5 other numbers up, and then somebody tells us what those numbers are, what that number is. Who added those 5 numbers up? What do we get? We have we have calculators. I don't know why. I don't see enough typing here. I don't see or hear enough typing. So, what do we get? Somebody get a number. Yup. 586 plus x. So now what's the last step to get the x by itself? That's all you do. This is algebra 1. So then the last angle is how many degrees? How many? 164? Try that subtraction again. 34. That's the last angle. Questions? So again, hexagon, 6 sides, sum of the angles, 720. They gave us the first 5, you find the last one. There you go. Questions about this one? All right. Okay, these next ones are going to be real quick. Zoom out a little. Okay, the sum of the exterior, some of the exterior measures of a nonagon. Well, it doesn't matter what side, how many sides you have. What's the sum of the measures of any and all exterior angles? Which one do we have? 1, 2, 3, 4, or 5? Sum of the exterior measures. So which one says sum of exterior angles? Which one out of the 5? Sum of exterior angles. Which one says sum of exterior angles? Look at our chart. Which one out of the 5? Sum of exterior angles. 1, 2, 3, 4, or 5. Who can tell us? Yeah, it's this one right here. Boom. 360. That's all. Doesn't matter if it's any polygon. So some of those exterior angles are always going to be 360. Now, what is the measure of each exterior angle? So if it's each exterior of a 20-gon, well, in this case, N is 20. So which one do we use? Is it going to be 1, 2, 3, 4, or 5? Somebody tell me real quick. Each exterior angle. Which one is it? The fourth one. So all we're going to be doing, 360 divide by 20. So what do we get? 360 divided by 20. 18. So again, it's all about reading the problem. Read that problem, that's going to tell us what we use. All right. Then one more slide. I know we're not going to get all the slides, but here's our last one that we're definitely going to review. Now, okay, let's put away that phone for the last time, so don't be crying to me when you don't have all the notes. Exterior angle, polygon measures 9 degrees. How many sides do we have? So in this case, which one are we using? Last one. Number of sides, there you go. So 360 divided by 9. We divide 360 by 9, what do we get? 40. Now, this one I want to talk about real quick. The interior angle is 108. Hold on, let me write this real quick. I'll type it. This is going to be the last one we talk about. Interior angle is 108. That must mean the exterior angle equals something else. Because what do we say about the interior plus the exterior? Interior angle, I'll just abbreviate it. Interior plus exterior must add up to how many degrees? Anybody remember? We talked about it a little bit ago. 180. So that means the exterior angle must be how many degrees? If the interior is 108, the sum of the two have to be 180. 72. That's your magic number. Remember, interior plus exterior is 180. We're not done yet. So then you take the 72. So then it's 360. Divide that by 72. It's going to be 5 sides. All right, here's what we have going on. Listen up before we wrap it up. The last of these slides, I'm going to give you a setup. Listen up. The last 4 slides, I'm going to give you the setup. They're in Schoology already. I'm going to review them with you at the beginning of next period. So We're going to only talk about these for a little bit. They've already been posted in Schoology, those last 4 slides. You can look them over, but you are responsible for them. We'll probably talk about them for the first few minutes of next class. All right, before we wrap it up, let's sit up. After school Wednesday, after school Thursday. Also, look at this. Because next class I am going to give a homework assignment. And don't forget, if you're missing anything, you better turn it in by the end of next week. Otherwise, that's it. Quarter's over.